Hello, this is Mr. Collier, and today we're doing the probability of combined events. So first we're going to look at what mutually exclusive means. What basically means there's nothing in common. There's no overlap between A and B. Okay, let me show you that it looks like in a Venn diagram. Actually, let's do that down here. Okay, so if you have a Venn diagram where A and B have nothing in common, then the Venn diagram looks like this. So another way to write that in symbols is probability of A intersect B, or the probability of A and B happening is 0. One ball is selected at random from a bag containing 5 red balls, 2 yellow, 4 white. To find the probability of selecting a red ball or a white ball. So these are mutually exclusive events because they can't both happen. Okay, or maybe that's another way I should say this here. Can't. So when we're talking about probabilities, it can't both happen. I guess the best way to say both these things is this way here. The intersection is 0. So the probability of getting a red ball or a white ball is just going to be the probability of red plus the probability of white. Okay, that only works if they're mutually exclusive. In this case they are. So probability of red is 5 over 11, and the probability of white is 4 over 11. So that probability altogether is 9 over 11. Okay, so next we have events A and B are mutually exclusive, and we're given a couple probabilities, so there's no context here. And it's asking for probability of A union B. That means the probability of A or B. And because they're mutually exclusive, you can just add these two together. So it's probability of A plus the probability of B. So it is simply 0.8. Now this is the intersection. This is the probability of A and B happening, and that is 0. That's the definition of mutually exclusive. They can't both happen. So the probability is 0. Okay, so let's look at, not mutually exclusive is obviously the opposite of mutually exclusive. And if the probability of A intersect B is not 0, then we have to actually subtract it, and that'll be clear if you draw a Venn diagram. Okay, you have an overlap. So if you add A and B together, you're basically adding this overlap twice. So that's why you have to subtract the overlap once. Okay, because you added it on twice. So that's how that works. So if it's not mutually exclusive, then you have to do this extra subtracting of the intersection. So if you roll a die, what's the probability of even or a number greater than 3? So it's the probability of even or a number greater than 3. We have to do probability of even plus the probability of greater than 3 minus probability of even and greater than 3. So the even numbers are 2, 4, 6, so there's 3 out of 6 ways for that to happen. Greater than 3 is 4, 5, 6, so that's 3 out of 6. And both of that can happen if you have a 4 and a 6, so that's 2 out of 6. Okay, and we add those together, we get 4 out of 6, or 2/3. Okay, next, independent events. If two events are independent, then the probability of A and B happening is just the product of the two events. So that only works if they're independent. So be careful, you have to make sure that they're independent before you just multiply the probabilities together. Okay, so if Giuseppe has a 60% chance of winning at tennis and Henry has a 75% chance, and this question they're not playing against each other, they're playing against other people. What's the probability they both win their matches? So that's probably Giuseppe wins and Henry wins, which equals probability of Giuseppe times probability of Henry, which equals 0.6 times 0.75, which equals 0.15, or 15%. Okay, so what's the probability? Next one, what's the probability of Giuseppe wins and Henry loses? Again, these are independent, so you just do 0.6 times probability Henry loses is 0.25. Well, let me back up a bit. I think I have a mistake on this one. This was 0.75 times, so that's actually 0.45, and this one's 0.15, so 15%. Okay, next, Justin estimates the probability of passing mathematics is 0.8. The probability of passing English is 0.9. So what's the probability of passing both? Passing math and English is 0.8 times 0.9, which is 0.72, or 72%. Passing math but failing English. So that's the same as saying passing math and failing English. So that is 0.8 times failing English is 0.1. So that's 0.08, or 8%. Okay, passing exactly one subject. That means you pass math and fail English, or you fail math, pass English. We already have this answer, it's 8%. This one here, failing math, probability is 0.2, passing English is 0.9, so that's 0.08 plus 2 times 9 is 18, so that's 0.26, or 26% chance. Okay, next one, we have to explain why A and B are not independent. And you don't really need to know the context for these questions. You can just use this rule. If they're independent, then probability of A and B equals probability of A times probability of B. So that only works if they're independent. So if you know these probabilities and they're not equal, that means they're not independent. So the probability of A and B is 0.6, and probability of A times probability of B is 0.43 times 0.37, and obviously these numbers are not equal. Okay, so therefore probability of A and B does not equal probability of A times probability of B. Therefore A and B are not independent.